The today's outline of the class is software evolution. So in this point we covered program evolution dynamics, software maintenance. What do you mean by these 2 points? We see one by one. The first one is software evolution dynamics. So evolution dynamics is the study of the process of the system change. The system change due to many reasons. The previous class you show it, due to environmental changes, due to technical changes, due to any other. There are so many reasons. Based on that, software must change. So software change is inevitable. You know the previous class. So is the study of process of the system change. Program evolution dynamics means the process of system change. After several major empirical studies, the Lemons and Belody proposed that there were number of laws which apply to all the system. So in this law, there are two persons. One is Lemons and Belody proposed that there were number of laws and which apply to all the systems as they evolved, as they changed. So these law apply to all the systems. There are sensible observations rather than the laws. They are applicable to large system developed by large organization. So this law applies to all the systems. The Lemons law, see here in this given table, law and description. So continuing change is a law. So what is the description for this? Is program that is used in a real world environment must necessarily change. So when it is required for modifications or you have to add any new functionality in that software, so the change is required and else become progressively less useful in that environment. So the continuing change is one law. Similarly, increasing complexity. As evolving program changes, its structure tends to become more complex, and automatically when you add new structure, new functionality, so its structure becomes complex. Extra resources must be devoted to preserving and specifying the structure. So the increasing complexity is the second law, and so on. Large program evolution, organization stability, conservation of familiarity, continuing growth, declining quality, feedback system, all are the Lemons law. For example, feedback system. The evolution process incorporates multi-agent, multi-loop feedback system, and you have to treat them as a feedback system to achieve. What is the use for this system? To achieve significant product improvement. So the main purpose of feedback system is to achieve significant product improvement. Similarly, declining quality. The quality of system will decline unless they are modified to reflect changes in their operational environment. All these are the Lemons law. And applicability of the Lemons law. Lemons law seems to be generally applicable to large tailored system developed by large organization. So it confirmed in the early 2000 by the work by Lemons on the PEST project. It is not clear how they should be modified. Because of this reason, shrink wrap the software product system that incorporates significant number of commercial of the software costs, components, small organization, medium size or size system, and these are the applicability of Lemons law. The next point is the software maintenance. What do you mean by the software maintenance? So modifying a program after it has been put into the use. So after using, before you have to modify that software. Modifying the program after it has been put into use. The term mostly used for changing custom software and generic software product are said to evolve to create new version after modifying that software, so to create the new version. So maintenance does not normally involve major changes to the system architecture. So system architecture is not major changes. So maintenance does not normally involve major changes to the system architecture. The changes are implemented by modifying existing components. So you have to just you have to change it, modify it, component, arrays, pointer, structure. So all these components you have to just modify it and adding new functionality, new component to the system. So this type of change. So architecture changes not involved. And there are different types of maintenance. One is a fault repair, environmental adaptation, and functionality addition and modification. These are the three types of maintenance. Fault repair means changing a system to fix the bugs, means errors, vulnerabilities, and correct deficiencies in the way meet its requirement. After changing the errors, you have to meet its requirement. This is a one type, that is a fault repair. Environmental adaptation, so maintenance to adapt software to different operating system environment. So that product must cooperate with a different operating environment. The changing system so that it operates different environment, just as computer, operating system, etc. from its initial implementation. And functionality addition and modification, modifying the system to satisfy the new requirements. So all these changes, the main goal is to satisfy the new requirement or to satisfy the customer. And these are the maintenance cost if a distribution is shown. So functionality and addition or modification, it requires 58%, environmental adaptation 19%, and fault repair 24%. These are the three types of maintenance. So maintenance cost, so usually greater than development cost. So 2 into 100 into depending on the applications affected, both technical and non-technical factors, increases as software is maintenance. So maintenance corrupt the software structure, so makes further maintenance more difficult. So aging software can have high support costs, old language, compiler, etc. So it is usually more expensive to add new features to system during maintenance. So maintenance just correct the faults. So it is usually more expensive to add new functions to the system than it is add to same features during the development. So new team has to understand the program being maintained. Separating maintenance and development means there is no incentive for development team to write maintenance software. So there is no incentive. This is the main point. So program maintenance work is unpopular. Maintenance staff are often inexperienced, not experienced, and have limited domain knowledge. And as a program age, their structure degrades. After long use, their structure degrades and they become harder to change. So the next is the maintenance prediction. So prediction is concerned with assessing which part of the system may cause problem. So the main goal is assessing which part of the system may cause problem and have high maintenance cost. That is a maintenance prediction. So change acceptance depends on the maintainability of the components affected by the change. Implementing changes degrades the system and reduces its maintainability. The maintenance cost depends on the number of changes, and cost changes depends on the maintainability. So in this given diagram, maintenance prediction is given. Maintenance, predicting maintainability, predicting maintenance cost, predicting system changes. In the predicting system changes, you have to ask the question, which part of the systems are most likely to be affected by a change request? That is the predicting system changes. How many changes request can be expected? And maintenance, predicting maintenance cost, what will be the lifetime maintenance cost of the system? Question mark. What will be the cost of maintaining the system over the next year? So you have to predict it. Predicting maintenance cost, predicting maintainability. What parts of the system will be the most expensive to maintain? Predicting the maintainability. So all these are the maintenance prediction diagram. So change prediction, predicting the number of changes requires an understanding of the relationship between system and its environment. So tightly coupled system requires changes whenever the environment is changed. Factor influence this relationship are number and complexity of system interfaces, number of inherently volatile system requirement, the business process where the system is used. So complexity matrix, prediction of maintainability can be made by assessing the complexity of the system components. So the main aim is assessing the complexity of the system component. Studies have shown that most maintenance efforts is spent on relatively small number of system components. So complexity depends on all these three factors: complexity of control structure, complexity of data structure, object methods, and model size. So process matrix. So process matrix may be used to assess maintainability. So matrix is used to assess maintainability, number of requests for corrective maintenance, average time required for impact analysis, average time taken to implement a change request, number of outstanding changes, all these requests. So to assess maintainability, that is the process matrix. If any or all of these is increasing, this may indicate decline in maintainability. So all these PPTs are taken from Anne Somerville, 9th edition. Thank you.